Touching a vTable is like touching a soul, the ethereal essence of polymorphism, the very building blocks God used to create a child class. Hey everybody, Sluggernaut here. Yeah, I just wanted to talk about a couple of basic things with the vTable today. I'm getting asked a lot of odd questions about the vTable in interviews, and a lot of them are down to earth, but some of the questions are a little odd. They're kind of leading me to believe that the interviewer doesn't know about the vTable in depth, and they're asking me questions about them, and I'm answering them as far as I can tell correctly. But anyway, it's a whole thing. So let's kind of look at what I'm talking about. Let's look at some general confusions I think I'm seeing that programmers have about the vTable. So we've got some pretty basic stuff here. We just have a parent class and a child class. We have one protected variable called our text. I commented it out here, of course, just to kind of remind ourselves that we have this variable. We've inherited it, and it's protected, so we can touch it and everything. So and then all these do, we have virtual functions in both classes, of course, and we inherit and uh, overwrite the print function, right? We have our own interpretation um, of this print function where we're going to print child print size and the size of our class rather than the parent that would print parent size and the size of the class. Now we can kind of see that these should be the same size. They should be the size of a single pointer, wink wink, and that's kind of it. There's no trickery going on. I'm not doing anything weird. These are about as basic as it gets while showing inheritance. And we are going to do one weird trick that you should never do, and we'll kind of talk about all that. And this is, I think, when we get past those just ultra basics where the confusion comes in. So let's just hit F5. And actually, we don't need this breakpoint yet. So we'll just run that. We'll take a look. And we see that the parent printed its size of 16, and the child printed its size also 16. 16, that's kind of odd. This is a 64-bit process, so we should have a 64-bit pointer, which is 8 bytes, but this is 16 bytes. So why do we have 16 bytes? Is it padding? No, of course, it's our vTable pointer. And so let's just go ahead and take a look at the vTable pointer. If you didn't know, you can look at your vTable pointer. And when we look at a vTable pointer, we should see that it looks at and shows, so let's take a look at one, VF pointer, underscore, underscore VF pointer, and it shows print and print char. What are these functions? These are the virtual functions that we have. We don't have a virtual destructor or anything like that, just those two. So those are listed here, and though that pointer is what is increasing the size of our class. So if we have a virtual table pointer, can we touch a virtual table pointer? Yes, absolutely. You shouldn't, but absolutely you can. Nothing stops you. I'm not going to stop you, that's for sure. So let's just do something like memcopy. Let's go into the parent. If I can spell parent, child, and we'll do size of parent class, and then we'll do parent1 print. Now, as we saw just a moment ago, parent1 print prints parent print size and then the size of the class. And we should get that same output. It's still a parent. All we've done is copy the contents of the child into the parent. We would generally expect, if obviously there's a trick here, but we would generally expect to just copy the only data members in the class. But let's see what happens. So when we look at this here, we see that we printed our parent print, child print, parent child 1, and then child print size 16. Well, that's coming from the parent print. What's going on here? Well, we did a memcopy and copied the child's vTable over the parent's vTable. So for all intents and purposes, as far as the instruction pointer understands, looking at the vTable, it's going to follow the vTable into the child class and print what it finds. That's how it works. So you need to understand the instruction pointer. You need to understand the vTable, how it's constructed. You need to understand the vTable is not a data member of a class, but is explicitly, but it is like an implicit data member. Um, it is not static. I remember I did that, and by remember, you probably haven't seen it because who cares? But I did a long form video a long time ago on the static data members. And if you have a static data member, it is not included with the rest of the class. When you get the size of a class that has a static data member, you will get the size of it without that data member. If you get the address of the data member, the static data member, and the class itself, they will be worlds apart. They will not be anywhere near each other. So if we did have a static vTable, if there was some way to do that, we wouldn't have to worry about this. But it's not. It is essentially volatile memory. It is contiguous with the memory of your object, and it can be overwritten. Again, like I said, you should never program like this on purpose. The only reason you would need to know that this happens is to not do it, is to avoid it. This is a catastrophic um, uh, piece of behavior here that it is unlikely you ever want this to happen. This is not polymorphism. I wouldn't say this isn't casting. This is god awful. So anyway, just essentially be careful. Like the actual thing we want to do here is have some sort of copy constructor or move operator um, to handle this kind of stuff, and never use memcopy if you have virtual functions. Memcopy is great if you don't have any virtual functions, if you're not using polymorphism, but otherwise you need to be, yeah, just extremely careful. So that's kind of it. If you've never actually just looked at the vTable and noticed it being here, you should. If you didn't know that you could overwrite your vTable, if you use zero memory on the parent, and then let's say oh, okay, well, this pointer's out of whack, and you changed it, right, updated it after zero memory. Well, your vTable is still zeroed. You would have a null pointer for a vTable, and as soon as you try to use any virtual function, you would absolutely crash. So anyway, I just want to kind of throw that out there as like an odd sort of gotcha. And yeah, if you want more videos on the vTable, the instruction pointer that nobody ever talks about, contiguous memory, let me know in the comments. I'd love to know what people think they're being sort of confused by, tricky gotcha questions from interviews, anything like that. I'm always interested in these kinds of things. And again, my issue is that I understand all of these things, and I think a lot of engineers probably do, and then some don't, and those some might be interviewing you. Again, I know I sound salty, like, oh, like they didn't know and I did or something. No, I actually, in one of my last interviews, had a very nice conversation and told them about this behavior and asked them if they knew it existed. And they said no, which is, again, this is fine. This doesn't mean I'm a better programmer than them or worse. And I guess that's kind of what bugs me about it, is that I'm being asked sort of arbitrary questions about odd behaviors in the in the vTable, for instance, or in programming, and that has nothing to do with my skills as a programmer. Um, and so, yeah, just kind of odd. I do think there are better ways to conduct interviews than that, for sure. Um, but it's hard to say what, right? I'm not a very fast coder. I'm definitely not a good live coder because I can't really talk and listen while coding. So it's very hard for me. If you and I were doing paired programming together, I'd have to pause a lot if I'm the one doing the programming. So anyway, yeah, that's it, I think. Let me know what you guys think.